So for today, what we're going to be getting into is your oil solenoid valve, or better known as your oil delay valve. So the solenoid is a valve that is electronic. Okay, it's composed of a coiled wire that is energized and creates magnetism. So it kind of sounds familiar if you're dealing with relays and contactors. It almost operates off the very same concept. So that magnetism is going to either open or close the valve. Okay, a valve that is open when de-energized is considered a normally open valve, and when a valve that is closed when de-energized is considered a normally closed valve. Solenoid valves are used in both older and newer high-pressure gun burners. If you're dealing with older burners, it may not necessarily be directly on the oil pump itself, but it could be in line, like in the oil line somewhere. Usually the older burners, were going to be field installed, which basically means that you would actually install it. Newer burners have the valve actually included on the burner itself. So the burner, or the valve itself, actually serves really two purposes. It's going to delay the flow of oil to the burner at startup, and it also provides a clean shutoff of flow of oil when the burner actually shuts down. So this is the device that we're talking about right here. This guy that's up here. This is our oil solenoid valve, or our oil delay valve. Use or find on your Beckett clean cut pumps, or it would probably look like something similar to this. It would be connected in the oil line somewhere. So delay at start solenoid valves, the oil pump is set at 100 psi or 140 psi in most cases. Okay, this pressure is based upon the burner motor operating the pump at full RPMs. So there is a brief period at the start of the burner cycle that the motor, pump, and air fan are not moving at full speed. So thus the oil delivered to the combustion chamber would not be at the correct pressure or velocity. So what we're doing when we're using the oil delay valve is we are allowing the burner, motor, blower wheel, and all that stuff to get up to full RPM so that we can deliver the correct pressure and velocity when we need it. So the oil solenoid valve is going to remain closed until that actually happens. Once that happens, then the solenoid is going to open and allow the correct pressure and air mixture to occur in the combustion chamber. Okay, we can also call this a pre-purge cycle if we are on a high efficiency boiler. If used as a pre-purge, the primary control must be set up for this pre-purge or it will trip. Some of our primary controls need to be set up for a specific operation. Not all primary controls have this feature, and if they do, you have to make sure that you read the literature to that primary control to make sure that it is set up for what we would consider a pre-purge cycle. If you are not, or if you are a customer, oil furnace or boiler, and are not able to solve a rough ignition problem through setting up pressures, cleaning, and air adjustments, install an oil solenoid valve and the problem will usually go away. When the call for heat is complete, the burner shuts down. There is a brief period of time where the pump is not delivering, again, the correct oil pressure to the nozzle. The oil will drip out at the end of the nozzle and cause a buildup of carbon at the end of the nozzle and in the combustion chamber. So by adding a oil solenoid valve, or better known as a clean cut pump, you are now eliminating that drip, or that after drip that we're discussing here. The use of the oil solenoid valve causes for a clean shutoff. The valve will close at the end of the call for heat and before the pump and burner actually loses pressure. The oil solenoid valve is placed on the jet line between the oil pump outlet and the nozzle assembly. You will need a second 1/4 inch line to connect this installation. For clean shutoff purposes, the oil solenoid valve is wired to the burner motor line from the primary control. Do not wire to the ignition transformer line if separate on the control, as the ignition transformer may not be operational through the entire cycle. Remember, you have intermittent and interrupted ignition. So here is a basic wiring diagram of what we're talking about. This is an 8184 Honeywell R3 wire. So we have black is our power, white is our neutral, and orange wire would be for our ignition transformer, oil delay valve, and burner motor. Okay, so for a delayed ignition or pre-purge, you must either use a primary control that has a separate line for the solenoid valve, use a solenoid valve with an internal delay timer. So make sure you test any installation prior to leaving the job. Run it through several cycles to be sure the delay will not trip the CAD cell safety. So here is one of our other primary controls. Now notice right here we have a little purple wire. This purple wire is for our oil delay valve. This blue wire with the white strip, that's our burner. This orange wire, or I'm sorry, the blue is for our igniter. Orange is for our burner. Black is our power. White is our neutral. The 2 yellow wires here are our CAD cell.